Just over 4 light years from where you are sitting right now, there's a star so faint you cannot see it with your naked eye, even though it is, by a wide margin, the closest star to our sun in the entire universe. Its name is Proxima Centauri, and for years, the James Webb Space Telescope has been quietly turning its enormous gold mirror toward it, trying to answer one of the oldest questions humanity has ever asked: is there anything else out there? Recent observations and a fresh round of headlines have reignited public fascination with this tiny red star, and some of that coverage leans hard into fear, framing the findings as something almost sinister, complete with dramatic thumbnails and ominous countdown-style narration. So let us set the record straight on 2 things at once: what Webb has actually found around Proxima Centauri, and why the true science, without any exaggeration at all, is still genuinely one of the more unsettling pictures modern astronomy has painted of our nearest stellar neighbor. First, a correction worth making before anything else. Webb did not just see Proxima Centauri for the first time. Astronomers have pointed the telescope at this system multiple times since Webb became operational, because it sits so close, astronomically speaking, that it is one of the most valuable targets available for testing whether we can directly detect small, rocky, potentially habitable worlds around another star. What has actually been happening recently is more precise and, honestly, more interesting than a first glimpse. Scientists have been running increasingly sophisticated observing campaigns, testing whether Webb's instruments, specifically its mid-infrared, camera paired with a coronagraph that blocks out a star's blinding glare, are sensitive enough to spot the faint heat signature of an Earth-sized planet hiding in Proxima's uncomfortably close orbit. That is a genuinely difficult technical challenge, because Proxima Centauri is a red dwarf, small, dim, and cool compared to our sun, which sounds like it should make planet hunting easier since there is less starlight to block out. In some ways it does, but it also means any potentially habitable planet has to orbit extremely close to the star to receive enough warmth to support liquid water, and squeezing a telescope's field of view tightly enough to separate a planet from its star at that distance, from 4 light years away, pushes even Webb's remarkable optics close to their absolute limit. Here is where the story gets genuinely worth paying attention to, because the system already has confirmed residents. Astronomers have confirmed multiple planets orbiting Proxima Centauri, the most famous being Proxima B, a rocky world roughly similar in mass to Earth, sitting inside what scientists call the habitable zone, the band around a star where temperatures could, in theory, allow liquid water to exist on a planet's surface. For a moment, when Proxima B was first confirmed back in 2016, it captured global attention as arguably the single most promising nearby candidate for a world that might resemble our own. And that is exactly where the more unsettling part of this story begins, because being technically inside the habitable zone and actually being habitable turn out to be 2 very different things once you understand what kind of star Proxima Centauri actually is. Red dwarf stars like Proxima Centauri are notorious among astronomers for a specific, well-documented kind of violence. Despite being small and dim compared to the sun, they are prone to sudden, extraordinarily powerful flares, eruptions of radiation and charged particles that can, in the most extreme recorded cases, around similar stars, briefly outshine the star's own normal light output by a factor of 10 or more within just a few minutes. Because a habitable zone planet around a red dwarf has to orbit so close to survive the star's otherwise weak warmth. Any planet there sits directly in the blast radius of those flares, at a distance far closer than Mercury sits to our own sun. Proxima Centauri itself has been directly observed unleashing flares dramatic enough that astronomers monitoring the system in visible and radio wavelengths have recorded sudden massive spikes in brightness lasting only minutes, consistent with some of the most powerful stellar flares ever documented around any star of its type. Instruments watching the star around the clock have caught it erupting repeatedly over the years, not as a rare anomaly, but as part of a recognizable recurring pattern, the kind of behavior that has led some researchers to describe Proxima Centauri as one of the more magnetically active small stars within easy observing distance of Earth. Run the physics forward across the billions of years Proxima B has likely orbited its star, and you arrive at a genuinely sobering picture. A world that might have started with an atmosphere similar in principle to Earth's could have had that atmosphere gradually stripped away, layer by layer, flare by flare, by a star that never really calms down. Scientists studying the system have explicitly raised this scenario as one of the more likely explanations for why Proxima B, despite sitting in the theoretically habitable zone, may in practice be a bare, irradiated rock rather than anything resembling a living world. This is precisely why the newest wave of observations matters so much, and why researchers have not given up on the system. Despite that grim possibility, If flares really have scoured the inner planet bare, then any hope for a genuinely temperate, potentially life-bearing world in this system would have to lie further out, in an orbit distant enough to escape the worst of the radiation while still catching enough of the star's feeble warmth. That is exactly the needle astronomers have been trying to thread with Webb's most recent coronagraph observations, testing whether the telescope's infrared vision is sharp enough to detect the faint thermal glow W of an Earth-sized world in a slightly more forgiving orbit, one that current data has not yet ruled in or out. The honest scientific answer, as of the most recent published analysis, is that Webb's instruments are right, at the ragged edge of being sensitive enough to make that detection at all, meaning any signal researchers do eventually claim will need to be treated with real caution, checked and rechecked against the ordinary noise and glare inherent in trying to photograph something so faint sitting so close to something so relatively bright. It gets even stranger and even more genuinely compelling once you widen the lens slightly to the rest of the Alpha Centauri system that Proxima Centauri technically belongs to, orbiting its two brighter sibling stars, Alpha Centauri A and Alpha Centauri B, from a considerable distance. In a separate but related string of observations, Webb has picked up what researchers describe as tantalizing, if still unconfirmed, evidence of a than the dim red dwarf Proxima. Getting even that faint signal required an extraordinarily delicate observing technique, using a chronograph built into Webb's mid-infrared instrument to physically block out the overwhelming glare of Alpha Centauri A, in much the same way you might cup a hand around a bright light to see something faint sitting just beside it, except accomplished with an optical precision fine enough to separate two objects that, from Earth's distance, sit almost on top of each other in the sky. That signal has proven maddeningly inconsistent. It showed up in one observing window, then genuinely vanished in follow-up attempts, only for computer simulations to suggest the missing planet might simply have swung, at the time of the second look, into an orbital position too close to its blindingly bright star for Webb's coronagraph to separate the two, essentially hiding in plain sight behind its own parent star's glare. Astronomers involved in the research have been candid that the signal sits at the very limit of what current image processing techniques can reliably pull out of the data, and they are hoping for another clear, observing opportunity, expected around August of 2026, to either confirm the planet is real or rule it out entirely. If it turns out to be real, and if it truly sits within Alpha Centauri A's habitable zone, it would represent one of the most significant exoplanet discoveries in the telescope's entire history, a genuinely temperate world orbiting a genuinely sun-like star in the very system next door to our own. And unlike Proxima's inner planets, one that would not have to contend with anywhere near the same relentless flare activity. So why lean into a word like terrifying for a story that includes some perfectly wondrous science alongside the harsher stellar physics? Because there is something quietly humbling, even unsettling, about what this system keeps teaching us the closer we look at it. For decades, popular imagination treated the nearest star system to Earth as an obvious first stepping stone for the search for alien life, close enough that generations of science fiction imagined starships eventually setting a course directly for it. What the actual data increasingly suggests is a far more hostile neighborhood than that easy assumption ever accounted for. A red dwarf capable of flares powerful enough to plausibly strip a rocky planet's atmosphere down to bare stone. A habitable zone world that may have spent billions of years being scoured by its own star rather than nurturing anything resembling life. A tantalizing second candidate planet around a friendlier sun-like star that keeps appearing and disappearing at the very edge of what our most powerful space telescope can even detect. None of that is science fiction. It is the honest, still unfolding picture assembled from real spectroscopy, real coronagraph imaging, and real flare monitoring, carried out by working astronomers who are themselves the first to say the data is not yet finished telling its story. There is also a genuinely eerie undertone buried in the flare data itself that deserves to be said plainly rather than glossed over. Some of the largest flares recorded from Proxima Centauri have been powerful enough that, had a comparable eruption occurred on our own sun, it would represent an event dramatically more extreme than anything in recorded human history, capable of threatening satellites, power grids, and the ozone layer of an unprotected planet many times over. Proxima b, sitting in an orbit roughly 20 times closer to its star than Earth sits to the sun, would absorb the full, undiluted force of an eruption like that on a regular basis, not as a rare, once-in-a-century event, but as a routine, recurring hazard baked into what it would mean to simply exist in that orbit. It is one thing to read that a nearby world sits in a theoretically habitable zone. It is another thing entirely to understand that the same star making that world theoretically warm enough for liquid Water may also be, quite literally, sandblasting it with radiation on a schedule measured in months rather than millennia. None of this closes the book on Proxima Centauri or on the broader Alpha Centauri system as a target worth caring about. If anything, the uncertainty is precisely what keeps astronomers coming back with better instruments and more patient observing strategies, because a definitive answer in either direction would represent one of the most important data points humanity has ever collected about its own cosmic neighborhood. A confirmed sterile Proxima b would be a sobering, valuable lesson about the real limits of habitable zones around violent, flare-prone red dwarf stars, the most common type of star in the entire galaxy, meaning the lesson would echo far beyond this one system alone. A confirmed temperate planet around gentler, sun-like Alpha Centauri A, on the other hand, would instantly become one of the most closely studied objects in the history of astronomy. A genuine, physically reachable, at least in theory, a candidate for a second Earth sitting in our own galactic backyard. For now, the honest summary is this. Webb has not delivered a single dramatic final photograph of a living or dead world next door. What it has delivered is something slower and, in its own way, more remarkable. A steadily sharpening picture of just how violent, unpredictable, and genuinely strange our nearest stellar neighbors actually are, built one careful, heavily scrutinized observation at a time. The terrifying part of this story was never a monster hiding in the data. It is the plain, well-documented physics of what it actually means to orbit a star that never quite calms down, and the quiet reminder that the search for another Earth may ultimately depend less on finding a planet in the right place and more on finding one lucky enough to be circling the right kind of star in the first place. If this gave you a clearer, more accurate picture than the panic headlines usually offer, a like helps more people find the real science instead of the exaggerated version. And subscribing means you will not miss where we go next.